Hello everyone, this is part 3 of my Nixie tube clock project. Sorry for not uploading in a while. It's been like 3 weeks since my last video, but in those 3 weeks I've been working very hard on this project. Most of that time has gone to the PCB design, because I've never done that before, and that was way harder than I was expecting it to be. But I've also got some improvements to the breadboard design to show you, and so I'll show you that in a bit, as well as just talk about a little bit more what the final design is going to look like. So here is the PCB design. I apologize in advance, by the way, because I'm just going to be recording the laptop screen with my phone camera. I know that's not the best way to do it, but I just couldn't really find an easy way to have it transition from the laptop screen recording to the phone recording, so I'm just going to do it this way. I apologize for the bad quality. But anyway, so as I mentioned in the last video, the design is going to be divided into two boards stacked on top of each other. So this is going to be the top half, and the top half has all of the Nixie tubes on it, as well as all of the driver chips and a connector to the bottom half, as well as some holes for some of the components on the bottom. And then the bottom half is going to have the Raspberry Pi, the lights, and the button that are going to poke through at the top, and some power management stuff. So as you can see on this board, there are a lot of traces going in between all the components. It took forever to route all of these. At first I tried to do all of them by hand, and I realized very quickly that that wasn't going to work. So I used an auto router program, and I ran that, and I waited and waited, and it ended up taking 2 hours to optimally route all of these. So I'm just going to leave that as is. I trust that program. Although, to be fair, I did ask one of my friends who's an electrical engineer to review this design, and he said it was all good, so I'm going to take his word on it. And then, of course, the bottom layer, as you already saw, is nowhere near as complicated, but, you know, still took a while to figure out how this software worked because I've never used it before. So now that I've got this all designed, I'm going to be sending it off to a PCB manufacturer so that they will fabricate this and send it to me. And the PCB manufacturer I'm going to use is this video's sponsor, PCB. No, I'm kidding. No, as if I would get sponsors. I'm choosing a PCB manufacturer named Osh Park, and I'm choosing them for two reasons. One, because they are American-based and they're pretty cheap, and two, because they have this really cool service called After Dark, where they make the PCB black, and it has a transparent solder mask, so you can see all of the individual traces going around the board, and it looks super cool. Of course, I don't have it yet. I haven't even ordered it yet, but I do have this 3D simulation of what it will look like when I have it in hand. As you can see, not all of the parts have 3D models. Of course, I couldn't find any models for the Nixie tubes, but this is just an example of what the board will look like. And as you can see, you can see all of the traces going everywhere, and it looks really awesome. I cannot wait until I have them in hand because they'll look something like this. So that's the top layer, of course, but I also have one for the bottom layer, which is a little bit less interesting, but that's why it's on the bottom. So that's what that's going to look like. Once I have all of this in hand, I'm going to solder all of these parts together, and then I'm going to go to a laser cutting place, which will make some laser cut acrylic sheets for me that I can use to enclose it. Because, of course, having a PCB this cool, it would be a shame to enclose it in something that you wouldn't be able to see it. So the whole thing's going to be transparent, and it's going to be covered in acrylic, and I think the final design is going to look super awesome, if I do say so myself. That'll hopefully be in the next part, so definitely stick around for that. I also wanted to show you some improvements I made to this setup here. As you can see, it's a bit messier now. Actually, this whole desk is pretty messy now, but that's okay. One of the things that you will probably notice right away about this is the button. So this, I mentioned in the last video that I wanted a 1970s-esque retro-styled button, and I saw this online and I just immediately knew that this was the thing I wanted. I don't know what it's actually made of, but it looks like it's made of brass or something, and I think it was originally designed for an elevator, and it's just like pressing it is so satisfying and I love it. But the button was kind of big. It's actually wider than the Nixie tube is. So I think in the last video I said I wanted 4 buttons, but I've reduced that down just to the 1 button, partially to save space, but also for ease of design, because I think having 1 button that switches between all the functions is a little bit more user-friendly, I think. Anyway, something else that I mentioned in the last video was these smaller Nixie tubes, and I actually got it working. So you will be able to see in the demo that I'm about to do that it'll turn on and off when a certain function is showing. I've also got this buzzer here. I think that was always on the breadboard, but I had never had it hooked up before. You'll definitely hear that when it turns on. Something else that I've improved about this design that you will not notice is that instead of running on 12 volts, it runs on 5 volts, because I was looking at the design and I have this, chip to convert it from 12 volts to 5 volts, and I realized, like, nothing actually uses 12 volts on this board. I was like, why was I converting from 12 volts to 5 volts when I can just have 5 volts on the input? So it's a much better design for that, first of all, just to make the design simpler. But second, because 5 volts is what USB uses, so I could technically make this clock USB powered. USB power is cool because it'll allow me to just use any USB power brick I have lying around as the power source, as opposed to having to rely on a 12 volt power supply, which is a little bit harder to find. And so to interface all of these new components that I've added, I've written a new program for the Raspberry Pi Pico, and this new program is designed to show off everything that this clock is going to be able to do once it's finished. So I'm going to turn it on now. Yep, so there you see the 5 volts. And so right now it is connecting to the internet. So I have, just like I said in the last video, I have the 2 decimal points going back and forth as the little loading screen. And now that it's connected to the internet, it's counting up numbers. But unlike last time, these numbers aren't just counting up, they are the actual seconds on the clock. So I'm going to show you my watch here, as you can see, if I can get it to focus. Come on. Okay, yeah. This is like 49, 50, 51, 52, right? And then it's, oh, okay, well, this is a little bit ahead, actually, or this is a little bit behind. But what it did was when I started it up, it connected to the internet, and it got the real time, the real current time, and now it is counting up the seconds, and it's showing the seconds on the clock. Obviously, this is just the rightmost digit of the seconds right now, but when I have more tubes, it'll be able to show both of the seconds digits as well as the minutes and the hours. And so I've got this button here, and this button will switch the function. So you heard the buzzer there, and it switched the function to the date. So this is the rightmost digit of the day. So go back to my watch. Today is August 25th, and that is a 5. And then, of course, the one next to it would be a 2, and then it would also show the month and the year. So now, here's where it gets really cool. If I push it again, it'll connect to the internet again, and it'll pull the weather. So this is a 7. This is the rightmost digit of the current temperature outside. And if you look at my watch again, yep, it is 87 degrees outside, and that's a 7. So it's actually pulling the real weather data off of the internet, and it is showing that on the tubes. And then, oh, I almost forgot about this. So this light turned on to indicate that it is on the weather mode. And so this will be the light that lights up when it is showing the weather. So when I push this again, all of the tubes will turn off. This is like the final function that I have programmed in right now. This is just kind of a power saving mode so that the tubes aren't on all the time, and it'll preserve power and also preserve the life of the tubes. So push it again. Yeah, so it'll go back to counting up the seconds. So what's next from here? Well, I've pretty much shown you everything that I possibly can show you. I mean, I've shown you a simulation of what it will look like when it's finished, and I've shown you a simulation of what the software will look like when it's finished. Really, the only thing I can show you after this is what it actually looks like when it is finished. But of course, for it to be finished, I have to wait for this PCB to be manufactured and mailed to me, and then I have to take all of these components and solder it on. I have to write a new program for the Raspberry Pi, but I really am getting close to the finished product now, and I'm really excited for it to be finished, and I'm really excited to show you when it's finished. So, as usual, subscribe, and hopefully the next part, whenever that next part is, will be the finished product. So I will see you in the next video. Bye.